Hey, it's Mr. Pomeroy here, and I'm making this video to help students with thinking with mathematical models, Investigation 1. The big ideas in this first investigation are recognizing linear and nonlinear patterns in tables and graphs and using these patterns to make predictions. Throughout this book, students will use tables, graphs, and equations to explain real-life situations. This video is designed to be helpful to students and parents for the first investigation in our book. Feel free to pause the video at any time. Some people like to watch the video before they jump into the problems and the homework, and other people like to do a little bit of the homework and then check as they go. Use this video however it helps you. I will actually break this video into 4 parts. One for problem 1.1, which will be this video, another one for problem 1.2, a third for problem 1.3, and a final video for the homework questions from the 8th section of the book that go with the investigation. This video is specific to problem 1.1. The first investigation in our book is called Explore Data Patterns, and it uses a construction theme to connect ideas to something students are familiar with in real life. Problem 1 explores bridge building and the beams used to build such bridges. So the first problem, problem 1.1, dives right into bridge building. And before we start an experiment, the students are asked the following questions. How do you think the thickness of a beam is related to its strength? Do you think the relationship is linear? And what other variables might affect the strength of a bridge? My students usually predict that the thickness of a beam is related to its strength, as the thicker the beam, the stronger the beam will be. They also tend to predict that it will be somewhat linear in relationship, and they predict that depending on what materials you use, the bridge can be more or less strong, as well as the design of the bridge can affect its strength. And finally, sometimes students predict that the length of the beam will affect its strength, as the longer it has to span, the weaker it will be, and the shorter it spans, the stronger it will be. They don't always predict this right away, and that's okay. So then our book leads us through a bridge building experiment. We simulate a bridge by having folded paper that spans across 2 books of equal height. In the middle of the bridge, we place a cup, and we add pennies to the cup until the bridge is compromised in its strength. We start with 1 thickness of paper, and we record on a data table how many pennies that bridge would hold. Then we increase by 2 thicknesses and 3 thicknesses and so on. The lab sheet for problem 1.1 has 3 sets of student data at the top. All the data is somewhat similar and yet a little bit different because each group would get different results in real life. After students examine the data, they are asked to do a few things with the data. And the first thing is they're asked to graph each set of data on the same coordinate grid in different colors. Then they are asked to record the results of their answers to the questions on the back of their paper in complete sentences, and they're asked to make predictions about what each group would get if their bridges were 6 layers thick. So here we have a graph of 2 different results from different class periods, and students were able to pick different intervals and different ways to graph it, but what they have in common is both of them have a title on their graph at the top about what the graph is about, and that's important when we're graphing. Both sets had the x-axis identified and the y-axis identified on their graph, and then labels for the variables. And we decided that the variable on the x would be the thickness in layers of the bridge, and we would see if that had any determination of how the breaking weight changed. And so that was the y variable right over on the y-axis, the breaking weight and the number of pennies that the bridge would hold. You'll notice that there are 3 different sets of data graphed on each one, different colors for different groups, and on our lab sheets we color-coded those as a class. So in class, we also discussed the different ways to graph the same data. As you compare these two graphs of the same data, they look slightly different. They both have the same information, but on the left one, on the x-axis, the interval, we went by ones and we didn't skip a line. On the right-hand one, this class decided that to use more of the graph paper, they would go by ones but skip a line. Both classes decided that they wanted to make sure that all the data fit in the table in a reasonable way, but one class had an interval of 4 for the weights of the pennies, the number of pennies, and the other class went by 5s. They yield similar results. And then from these results, we go back to our original questions. Is this linear? And we answered this in a couple different ways. One would be that one group was completely linear, and the other two groups approached linear but weren't linear. And then a different way to answer that question is, it isn't exactly linear as it is shown in the data table completely, but if you were to average the three groups, it would probably be linear. You can see that one of the groups in each of them, the second group, is linear. And so we talk about what that means is that as one variable increases, the other variable increases by the same amount each time or at a constant rate of change. And on a graph, you would see that as a straight line. In a table of data, you would see that as a constant rate. And then we also follow up with, did that match our prediction? The students predicted that as the thickness of the beam increased, so would the amount of pennies that the bridge would hold increase. And that's what we see in our graphs. Well, I hope this video has helped you with problem 1.1 from Thinking with Mathematical Models. Feel free to watch the other videos in this series for the help with the other problems and the homework. Also, feel free to email me with questions or comments at this email address.